Hey you guys, today we're going to talk about the polar form of complex numbers. So we know that z equals a plus bi is the rectangular form of a complex number. Well, z equals r times the cosine of theta plus I times the sine of theta is the polar form of a complex number. But we like to shorten it up to r times the cis of theta. And where this comes from is the c out of cosine, the I for the imaginary, and the s for sine. So it's a lazy math way to say something. All right, and I want to tell you where the cosine of theta and the sine of theta, all that stuff came from. So if we come over here, we know from before, when you graph a complex number, A would be you would go over that many on the real axis to the right or the left. And then whatever B was, you would go up or down that many, depending if it was positive or negative. So we have our point right here, and I just picked a random spot for a complex number. Well, what we can do is turn that into a triangle, just like we do when we do unit circle values. And I'm going to call this angle theta. So if I wanted to know what the cosine of theta is, we know that cosine is adjacent over hypotenuse. And in this case, remember from the previous lesson that the distance from the origin to a complex number is its modulus. So this would be the modulus of the complex number. But for these polar coordinates in the polar form, we're going to call it r for radius. So the cosine of theta would be adjacent over hypotenuse, which is a over r. And if I wanted to get the a on a side by itself, I would multiply both sides by r. So I'm going to multiply by r over here and r over here. These r's would cancel out, and I would get r times the cosine of theta is equal to a. So I'm going to come down here. A is the same thing as r times the cosine of theta. And let's go over here and look at the sine of theta. We know that sine is equal to opposite over hypotenuse. So opposite would be b. The hypotenuse is r. And if I wanted to get b on a side by itself, I'd pretty much do the same thing. I'm going to multiply both sides by r. And we get that r times the sine of theta is equal to b. So I'm going to come over here and put b is equal to r times the sine of theta. So when we're thinking about a plus bi, and I plug those values in. So if I had an a plus bi, and we know that a is the same thing as r times the cosine of theta, and we know that b is the same thing as r times the sine of theta, and you've got your I there. They both have an r, so I could factor that out front. So I would have r times the cosine of theta plus, and I'm going to bring the I out front, I sine of theta. And that's where this polar form came from, is this right here. All right, let's do some examples. Make sure you have time to get that. All right, so for our first examples, what we're going to do is graph some of these things that are in polar form. All right? All right, so the first thing we're going to try graphing is cis pi over 4. All right, so I'm going to write this in the long polar form. So remember, that's r times the cosine of theta plus I times the sine of theta. Well, r is whatever's out front here. I don't see anything, but I know that there's a 1. So r is going to be 1 times the cosine, and theta is pi over 4. Pi over 4 plus I times the sine of pi over 4. All right, well, we know these values. That's just off the unit circle. So I'm going to drop the 1 here because we don't need it. So that would be the cosine of pi over 4 is the square root of 2 over 2 plus I. The sine of pi over 4 is also the square root of 2 over 2. So remember, we could write this as an ordered pair. That's the square root of 2 over 2, comma, the square root of 2 over 2. Now, since I'm going to be graphing this on a rectangular coordinate plane, I might want to think about the decimals. So this is the square root of 2 over 2 is approximately 0.71. So if I wanted to graph it, let me get my graph paper. Okay. I would go over 0.71. I'm going to say that's about right here. I would go up 0.71 and plot my point, and that's it. All right, let's look at another example. All right, this time we're going to do 2 times the cis of pi. So the formula again is r times the cosine of theta plus I times the sine of theta. And this time r is 2. So that's 2 times the cosine. And for theta we're going to put in a pi. Plus I times the sine of pi. Alright, well the cosine of pi is -1. And the sine of pi is 0. So that's I times 0. Well, that's just going to go away. And we're left with -2. So we only have a real part. We don't have an imaginary part. So if I wrote that as an ordered pair, that would be the point -2, 0. So I'm going to get my graph paper again. All right, so -2, 0. I would go 2 to the left, and I wouldn't go up any. So place my point, and that's it. All right, let's do one more of these. For the last one, we have 2 cis pi over 3. So that would be r cosine of theta plus I sine of theta. And r again would be 2, so that's 2 times the cosine of pi over 3 plus I times the sine of pi over 3. All right, and then our unit circle values. The cosine of pi over 3 is 1/2 plus I times the sine of pi over 3 would be the square root of 3 over 2. All right, and I'm going to need to distribute that too. So 2 times 1/2 is just 1. And then 2 times 3 over 2, those would cancel. I'm going to come over here, 2. And if you multiplied that by the square root of 3 over 2, those would cancel. So you've got I times the square root of 3, or you can write that the square root of 3i. So that's the point 1 comma the square root of 3. And again, for graphing purposes, I'm going to approximate the square root of 3 is approximately 1.73. So I'm going to go over 1 and up 1.73. All right, so over 1, up 1.73. So right about there. Again, this is approximation. Okay, let's move on to the next part. All right, the next thing that we want to talk about is changing rectangular form to polar form. I can't really fit all that on there. All right, so 2 steps. The second one requires a little more thought. For step 1, you find r, and we talked about that before. R is just the square root of a squared plus b squared. That's just the modulus, right? And then to find theta, we'll use tan inverse and where it's located, because it matters what quadrant that it's in. So I'm going to do example 1 first. So we got -7 minus 4i. So r would be equal to the square root of -7 squared plus -4 squared, which would be, now -7 squared is 49, and that's 16, so that's the square root of 65. And for this example, I'm going to approximate and use decimals, so that would be approximately 8.06. All right, and now we want to find theta. All right, now remember, this is just the point -7, -4. So if I thought about graphing that point, so I'm just do a quick sketch. So -7, -4. All right, so I'm down here, and we're looking at this triangle right here. Now this actually isn't theta. Theta would be from this positive x-axis all the way to here. But if I find this angle, I can just add this and get theta. And I know from here to here is pi. So let's find this angle. So we said we went 7 to the left and we went down 4. So I'm going to do the tangent of, and I called this alpha, but you can call it whatever you want to, equals opposite over adjacent, so that would be 4 over 7. So we would want to do that theta was the tan inverse of 4 over 7. And I would just put that in my calculator, and then I get alpha is approximately 0.52. So theta is going to be that 0.52 plus pi. And I'm just put that in my calculator, approximate, and I get 3.66, and that's radians. So the polar form would be R, and R is about 8.06 cis, and then for theta we got 3.66, and that's it. So sometimes they do decimals, sometimes they leave it as radicals and fractions. Let's look at another one. I'm going to put a split down here. That's pretty ugly, but it'll be okay. We got 5 minus 5i. So again, I know that that is just 5 negative 5. And first we want to find r. So r would be the square root of 5 squared plus negative 5 squared. Well, that's 25. And that's 25. So that would be the square root of 50. And that can be simplified, right? Because 50 is 2 times 25. So 5 times the square root of 2. So r is equal to 5 times the square root of 2. And I'm going to leave that like that. So let's think about where this point is. We want to find theta. And again, I'm just going to do a quick sketch. Nothing beautiful. Over 5. Down 5. So it'd be about right here. Now this time, this triangle that I'm making is actually part of this positive x-axis. So I won't need to do any funny math. I can just use whatever I get for theta and I'm good to go. So this is 5 down and this is 5 over. So I'm going to do the tan inverse, or the tangent of alpha equals opposite over adjacent. So that's -1. So basically the tangent of what equals -1. So alpha is equal to the tan inverse of -1. And that would be negative pi over 4. And I want to point out that you could go the other way and get there also, right? So if this is negative pi over 4, if I went around this way, that would be 7 pi over 4. So I'm just going to put a little star here. Technically, both of those are right, but I'm going to stick with this. All right, so we got R, and we got alpha, which in this case is also theta because it's attached to this positive x-axis. So I am ready to go. So it will be R, so 5 times the square root of 2 and then plus, nope, let me try that again. Sorry. 5 square root of 2 cis negative pi over 4. And like I said, this could be 7 pi over 4. They might approximate that as a decimal. All that stuff's good. Okay. We're good. Let's move on to the next part. So the next thing we're going to talk about is multiplying numbers in polar form. And we have a formula for that. So if you have this number in polar form times this number in polar form, all you got to do is multiply your R and your S, and then add your alpha and your beta. So this is the long version, this is the short version. So let's look at an example of this. It is really easy. Okay, so to multiply these two that are in polar form, first I'm going to do 7 times 2 because we're going to multiply R and S. So 7 times 2 is 14. All right, so that's going to be my number out front. And then the next thing I want to do is add alpha and beta. So I'm going to say pi over 3 plus negative 5 pi over 6. I'm expecting y'all will put that in the calculator, but I'm going to find a common denominator. If I made that a 6, that would be 2 pi over 6, and then a plus and a negative, I'm just going to say minus 5 pi over 6. So that'll be negative 3 pi over 6, which is negative pi over 2. So my answer will be 14 cis negative pi over 2. Now that is the polar form. And let's say they want that also in the rectangular form. So we're going to use the formula that we used to graph. So the 14 goes out front, and that would be times the cosine of negative pi over 2 plus I times the sine of negative pi over 2. Now I'm going to use my unit circle values. The cosine of negative pi over 2 would be 0. And then I times the sine of negative pi over 2 would be negative 1. So that's 14 times negative I, or negative 1i, which is negative 14i. And that's the rectangular form. All right, let's do this the other way. It's not as much fun. So let's multiply in rectangular form, and then we're going to change what we get to polar form. So we're going to start off by doing some old school full method, then we'll change it to polar form. So, all right, full stands for first, outer, inner, last. So if I multiply my first two, I would have negative 1 times 5 square root of 3 over 2. Plus outer would be negative 1 times negative 5 halves I. Inner would be I square root of 3 times 5 square root of 3 over 2. And then last, I wrote too big, will be I square root of 3 times negative 5 halves I. All right, and then we got to do a lot of simplifying here. So this will be negative 5 square root of 3 over 2. A negative negative will be a positive. 5 halves I. All right, and then we have I square root of 3 times 5 square root of 3 over 2. So I know 2 is going to be in the denominator. All right, whoops. These two square roots are multiplied together. The square root of 3 times the square root of 3 is 3, and 5 times 3 is 15. So that'll be 15 halves I. And then this is a positive and a negative, so it's going to be minus. And then you have 5 square root of 3 over 2i squared. And now, remember, I is the square root of -1, so if you square it, you would actually get -1. So I'm going to put a little star, I squared equals -1. So if I plugged in a -1 here, this negative and negative would actually make a positive. So I'm going to make this a plus, scratch that out, and move on to combining like terms. So this is real. This is now real. So I have -5 square root of 3 over 2 plus 5 square root of 3 over 2. Well, those are going to cancel out. Then I have 5 halves I plus 15 halves I, which would be 20 halves I, which is 10I. All right, so 10I is the rectangular form of my product. So now we want to change that to the polar form. So remember, 10I is just the point. Now there's no real part, so that would be 0, 10. So we'll find R first. So R will equal the square root of A squared, which in this case is 0, plus B squared, which is 10 squared. So that's the square root of 0 plus 100. So the square root of 100, which is 10. So that came out pretty. Now let's think about where this is at in the coordinate plane. Again, a quick sketch. If I goes over 0 and up 10, I'm going to be right here. So what is the angle measure from here to here? And I know all you guys know that that is pi over 2. So in polar form, it would be 10 cis pi over 2. And I am done. That is the polar form of my product. All right. Now, let's do something really easy and fun. And that is finding the factors if I give you the product. And the wonderful thing about this is there are multiple correct answers. So here's our first example. We have Z1 times Z2, which basically means I multiplied a couple complex numbers, and this is what I got. What are those complex numbers? So the first thing you want to do is think of two numbers that multiply to give you 80. I think I'm going to use 8 and 10. All right? And then you want to think of two fractions, or with pi in them, that add to give you 2 pi over 3. And let's make our lives easier. I'm going to use pi over 3 and pi over 3. So, for Z1, it could be 8 cis pi over 3. And for Z2, it could be 10 cis pi over 3. But like I said, there's more than one right answer. I could have done 4 and 20, and I could have used pi over 6 and pi over 2, and that would have also worked, right? Moving right along. All right, now we want to talk about finding the power of a complex number. So if you have a plus bi raised to the n, that's r to the n cis n times theta. Now, if I had 2 plus 3i to the 5th, I could say 2 plus 3i times 2 plus 3i times 2 plus 3i, yada yada. That would take forever. So what we're going to do is change it around to polar form and then use our formula. So here's our example. We have 4 minus 4i. So remember, this is just the point. 4 negative 4. This is the rectangular form. So First, we're going to find our r, and r is going to be the square root of 4 squared plus negative 4 squared. So that'll be the square root of 16 plus 16, which is the square root of 32. And remember, the square root of 32, I could think of that as 16 times 2. So that's 4 times the square root of 2. All right, so the next thing we want to do is find our angle. So the tangent of theta would be equal to negative 4 over 4. So we do the tan inverse of both sides. So theta would be equal to the tan inverse of negative 4 divided by 4 is negative 1. And if you want to graph this, you're welcome to. So theta would be negative pi over 4. All right. So now we've got that z is equal to 4 times the square root of 2, what we got for r, cis negative pi over 4. All right. So let's use our new formula and plug this stuff in and be done. So we have, again, the formula is z to the n is equal to r to the n cis n times theta. So that would be z to the fourth, or 4 minus 4i to the fourth, is equal to 4 times the square root of 2 raised to the 4th power cis 4 times negative pi over 4. And then we'll simplify. So z to the 4th would equal, so you got to think this 4 is being raised to the 4th power. So that's 4 times 4 times 4 times 4. The square root of 2 is being raised to the 4th power. And then it would be the product of those two numbers. That is 1,024. And then these 4's will cancel. And you get negative pi. All right, so this is my answer in polar form. Now, if I wanted to change it to rectangular form without doing all that crazy multiplication I was talking about, I'll use my formula. So that would be r times the cosine of negative pi plus I times the sine of negative pi. So that would be 1,024 times the cosine of negative pi is negative 1. And the sine of negative pi is 0. That's gone. Negative 1 times 1,024 is negative 1,024. And that is the rectangular form. All right, you guys, I hope this helps. Have a great day. I will talk to you later.